Okay, so let's finish this section. Hopefully we won't ever have to do this again. Let me recap what we did last time. For this lecture, we talked about domain and range of a function, right? So domain is all the x values, all the input. You're going to have to look at the x-axis projected to the graph, right? And then for the range is all the y values or the output values. And we look at the y-axis projected to the graph. If the if there's a field circle on the graph, then that means you include that point, right? That endpoint. When we write it in interval notation, for the field circle, we use bracket, meaning you include the point, right? If it open circle or hollow dot, then the point at the endpoint is not included in the domain or range. If it no circle or an arrow, that means the function go on forever to infinity or negative infinity. The first function we learned about is polynomial function. Polynomial function has this form, right? So like a linear function, quadratic, cubic, quartic, all of those are polynomial function. The domain of the polynomial function is the set of all real number, right? It's a very easygoing function. It's smooth everywhere. Okay? The rational function is a function that composed of a polynomial function on the numerator and another polynomial function at the denominator. For this rational function, the domain will be anything but except for the denominator is equal to 0. Right? So all you have to do is set the denominator equal to 0, and then those values, and then you remove those values for the range. A radical function, radical root, right? Like square root, cube root, four root, fifth root, etc. Right? Those are now n is called the index, and f of x is the radicand. If n is odd, like cube root, fifth root, seventh root, then the domain will be all real number. If n is even, like square root, four root, six root, etc., then the domain will be whatever underneath the radical had to be at least 0. I mean, you set that greater or equal to 0, and then you solve for x. What if we have a combined function? Combined function is you have polynomial, rational, radical, all in one problem. So here, if the polynomial on the numerator, you do nothing, just leave it alone. If the polynomial is in the denominator, then you set that you factor it first, and then you set it equal to 0 and solve. And then at the end, you say it cannot be equal to that value. If a square root is in the numerator, then you set the radicand, whatever underneath the square root, is greater or equal to 0, and then solve. If the square root is in the denominator, then you set the radicand strictly greater than 0, because you cannot include 0, right? You cannot divide it by 0. And then you solve, and then those value will be included in the domain, right? All right, so let's continue. I think this is where we left last time. We solved 6b, so let's move on to 6c. 6c, well, the numerator is a polynomial, so we do nothing, right? That's the one I highlight in blue there. The radical, there's a square root in the denominator, so I'm going to set the radicand greater than 0. So here, this one right here, see I highlight in black above there. So that means x minus 3 has to be strictly greater than 0, and then you solve for x. Add 3 both sides. X is strictly greater than 3. That means interval notation, in, is from negative infinity to 3. Since 3 is not included, we're going to use parentheses. Right, D. We have a square root on the top. Square on the top. That means we're going to set the radican greater or equal to 0. So x minus 3 has to be greater or equal to 0. Add 3 both sides. X is greater or equal to 3. And then you have a polynomial in the denominator. Oops, I meant green. So that means x minus 6 had to be strictly, I'm sorry, that's the polynomial, not the radical. It cannot be equal to 0. Or let's just set it equal to 0 first. And then you solve for x. So x equals 6. And then you say it cannot be equal to 6. Okay. So how do I represent this in interval notation? If you cannot think in your head, draw it out. Right? You draw it out. Negative infinity, positive infinity. I have two values here. I have 3 and 6. Right. We exclude 6, so I'm gonna draw a hollow dot there to remind me that I cannot take 6. And then what else? Another restriction is that x has to be greater or equal to 3. So my second restriction is that it had to be from 3. 3 included. I'm gonna make this a hollow dot. 3 is included. But so 3 and the 6 is not included. So I'm gonna skip the 6 and then move on to the right of 6 all the way to infinity. Okay. So as you can see, the one we highlight in red, your final answer will be bracket 3, comma, all the way to 6, parenthesis to indicate that we don't include 6, union 6 to infinity. All right. E, the one is on the top. It's nothing we can do there. Now, however, on the bottom, we have a square root. It's already a factor for us, which is good. If you square root the function is in the denominator, you set the radican strictly greater than 0. So that means I'm going to set this right here. X minus 3 times x minus 6 is strictly greater than 0. This one's a bit more complicated because they have two binomials, right? So you're gonna set each of those equals 0. X minus 3 equals 0. You gotta remember the step. X minus 6 equals 0. And you solve for x. X equals 3, x equals 6. These are your critical number. That's step number 1. Once you have your critical number, you're going to put them on the number line. Is 3 and 6 included? No, right? It had to be strictly larger than 0. Remember, there's no equal side there. So remove that. So 3 and 6 is not included. I'm going to put the hollow dot here just to remind me so I don't forget. Also, if it's hollow, it's gonna have a parenthesis, right? And at the two end, it's always parenthesis as well. So if you look at the next step will be picking the test value. Between negative infinity to 3, I'm going to pick 0. Between 3 and 6, I'm going to pick 4. Any value you can pick. It doesn't matter. Somebody else can pick 5, 3.5, 4.5. It doesn't matter, right? Between 6 and infinity, I'm going to pick 10. And then what do you do with those test values? TP, test value. We're going to plug it into the original function, right? So plug it in here. If x is 0, again, we don't care about the value. We care about the sign, right? 0 minus 3 is negative. 0 minus 6 is negative. So negative times negative is positive. 4 minus 3, positive. 4 minus 6 is negative. So positive times negative is negative. And then we have positive here. Right? Because 10 is bigger than 3 and 6. All right, now which interval do we want? Well, you look at right here. You look at your original question, right? It's strictly greater than zero. So you want the interval that contain positive sign, right? So we want this and we want this. So your final answer will be from negative infinity to 3. And what else? Union 6 to infinity. Please practice on that, okay? All right, H of X, sorry, H of X. I can rewrite H of X like this. I can bring it in under one root. Remember, don't write this down. If I have a square root of 2 times square root of 3, I can combine the radicand together, right? So I can bring them under one root. Square root of 2 times 3, which is square root of 6. However, or same thing with the dividing, right? Square root of 2 divided by square root of 3 is the same thing as square root of 2 divided by 3. However, this is not true. If I have square root of 2 plus square root of 3, it is not equal to square root of 5. Right? Please don't do that. Right? Same thing with minus. Same thing with minus. If you have square root of 2 or you have square root of 3 minus square root of 2, it is not equal to 1, or because the square root of 1 is 1. But these are not true. Right? If it adding or subtracting, you cannot combine the radicand. Okay, so as you can see, let me highlight it in yellow. So, as you can see, if your square root function is in the numerator, set the radicand greater or equal to 0, right? So we set x minus 6 times x minus 3 greater or equal to 0. Well, the steps to solving this is very similar to this one. So at the end, let me skip all the way to the end. I'm not going through that again. Well, instead of at the 3 and the 6, instead of hollow, it's going to be solid, right? Because we do include 3 and 6. Why? Because it's a equal to, right? It has that little one more line there at the inequality, so the equal to. So that means 3 and 6 is included. And everything else the same. Oops, should be bracket because included. Everything else pretty much the same. The only thing different is you include the 3 and the 6. So your final answer will be from negative infinity to 3 bracket union 3 6 to positive infinity. Very much the same. The only thing is that you include the 3 and the 6. Now, the last objective, piecewise function. Now, let's talk about the definition of piecewise function. A piecewise function are function defined by using different equations, pieces of equations, right? For different part of their domain. So each equation has their own domain. The domain of the piecewise function, the domain of the whole thing, will be the union of the individual domain, individual equations. Right. So here, take a look at this one. It is piecewise function because I see two pieces, right? Hence piecewise. The first piece on the left, I see it go from negative in terms of x. It go from negative infinity to up to -1, right? Um, so the first one, as you can see here, let me highlight it in blue, right? I assume that it's gonna go on forever. So if you project up to the x-axis, it's from negative infinity up to -1, up to -1. Okay, and then the second one, I highlighted in red, it start from -1 to infinity, right? Okay, now which one is which? Which one do we choose? We have several choice here. Let's take a look at the blue one. Let's take a look at the blue one. Uh, this is what I can do. I'm going to pick 2 points. Pick something that is integer point. So that one and that one right there. See, I see. So that one will be -2, -3. And this one, the one below, will be -3, -5. Well, you have 2 points. You can construct a equation, right? Let's see, what is my slope? Slope m equal y2 minus y1. So let's say this is my x1. I'm sorry, that's my x2. Let's say that's my x2, y2. This is my x1, y1. So y2 will be -5. Let me do this first so I don't make mistake. I tend to make mistake with the little sign. So y2 will be -5. Y1 will be -3. X2 will be -3. X1 will be -2. -5 minus -3 means -5 plus 3, so -2. -3 plus 2 is -1, so 2. Slope is 2. Once you have the slope, you can do this. So y equal 2x plus b, right? We're gonna figure it out. What is b? The y-intercept. You can use either point. You can use this point or this point to plug it in. So let me use the first one, x1, y1. x1, y1. So y1 is -3. Use blue. -3 equal 2 times x. X is -2 plus b. Solve for b equal 1. So your final answer will be what? Y equal, so the blue one will be y equal mx plus b. M is 2x plus 1. That is the blue function. Y equal 2x plus 1. And don't stop there. It's the piecewise function. It's a piecewise function. So you gotta include the domain with it. So where does it start? It looks to me like everything before -1, right? So x has to be strictly less than -1. Agree? So that's my first function. My second function, the red one, we're gonna do the same thing. This one is slightly a little bit easier because I already know what is my y-intercept, my b, right? All I have to do is find the point, plug it in, and find m, right? I suggest you find the point that it has integer value. So this one right here, let's say 1, 2. So my b, I know my b is y equal mx plus 1. My y-intercept is 1. I need to find m, right? I'm gonna use this point right here. So y is 2. M is no. X is 1 plus 1. So m is 1, right? You solve for m is 1. So we're done, right? So the final answer will be y equal 1x, which is x plus 1. Again, and I guess we have to include the domain. So for the red function, it start from -1 moving forward. So anything after -1. So it's gonna be x gonna be greater equal to -1. The -1 is included. So that's my second function. All right, eyeball your option there. Which one is the correct answer? It looks like this one. It looks like this one is correct answer, right? Because it has my red function there, and then it has my blue function there. Find the domain and range of f and g of g. We kind of did it. So for the red one, we have x is greater equal to -1. X is greater equal to -1. Union. Let me do the blue one first. Let's do from left to right. Always do from left to right. So we do x is less than -1. Union x greater equal to -1. But of course, we don't want to write like that, right? It just scrap word. On interval notation, how would I write this? So x less than -1 will be from -infinity go up to -1, and -1 is not included, right? Because there's no equal. Union x is greater equal to -1 is included. So bracket -1 is greater than, so great go all the way to infinity. That'll be your domain. Now, this domain is special because we can combine them. It's not all, we don't always be able to combine domains, by the way. But sometimes we can, right? In this one, we can. So your final answer should be what? It looks like, to me, it looks like this. Here, my number line, -infinity, +infinity. Here's a -1. Well, the function go from -infinity to -1, but -1 is not included. So we do hollow dot. However, the second function, the red one, is kind of fill that part, right? Fill that little hole. And it's keep going. So at the end, ultimately, your domain will be everything. Right? Because I highlighted everything, do I? So the domain will be from -infinity to +infinity. And again, you don't always be able to combine them. In this case, it's kind of special. This one's your U-Try 2, Friday, January 13. Make sure you click on the correct U-Try. I think you have till Sunday night. A few more, and then we'll be done. State the domain of each function. For this one, they don't give you the graph. However, you can tell the domain by looking at the restriction that they gave you, right? So for the first function, let me highlight in blue, and here I'll highlight in red. For the first function, I have x is less than 0. I always draw it out. It helps. And I have 0 in the middle here. For the first function, it go from -infinity to 0. Is 0 included? Yes, it is. So I'm going to put a hollow dot there. I'm sorry, solid dot there. For the second function, it start from 0. However, 0 is not included, but it doesn't matter, right? Because it's already filled by the first one. So together, your final answer will be, because you highlight everything, I don't see any gap on my number line. So your final answer will be from -infinity to infinity. I would suggest you take a moment to do 9B before you keep watching. Again, I'm highlight this in blue, this in red. For the blue one, let's see, I have two value here. I have -1 and I have 0. I see -1, I see 0 because of that there. For the blue one, what happened? The blue one go from -infinity, so x is less than -1. Go up to -1. -1 is not included, so hollow dot. And then it skip, right? It's kind of skip a little bit, and the red one start at 0. 0 included, so solid. From there, go to infinity. As you can see here, you cannot combine the domain, right? You have two separate domain because there's a gap in between. So your domain will be from -infinity to -1, parenthesis, union, 0, bracket, because 0 included, to infinity. And that will be your final answer. See, in this case, you cannot combine the domain. Number 10, they want you to evaluate the function given input value. F of -1. Well, in order to do this, you have to find where's the input belong, which domain does it belong. -1, it looked like to me, I'm going to highlight this in so that I don't have to keep saying. I'm going to highlight this red. No, blue. Red. And then green. Right? So -1 is falling between -2 and 0. Right? So I gotta use the first equation. I gotta use the first, I'm sorry, function. Because negative, you say, which one do I pick? Do you pick all three? No, you don't, right? You gotta look at the domain. So -1 fall between -2 and 0. Hence, you gotta plug into the blue function. The blue function say something square plus 3, and that something now is -1. So -1 squared is 1, plus 3 is 4. What about b? F of 0. Where does b0 belong? It still belongs to the blue function, right? Because 0 is being included in the blue function. Um, so something squared plus 3, and that something is 0, is equal 3. I have a 15. Where does 15 belong? 15 is greater than 3, right? So it's got to belong to the green one because it say x is greater equal to 3. That's the restriction for that function, right? So that will be equal absolute value of something minus 3. And that something will be 15. 15 minus 3 is 12. Absolute value of 12 is 12. F of 1. 1 is belong to the red function, right? Between 0 and 3. So negative something plus 3. That something is 1. -1 plus 3 is 2. F of -4. Where does -4 belong? I don't see anywhere, right? Even the smallest value for this piecewise function is start from -2, right? -4 is smaller than -2, so it's way out there in the outlier. Right? So nothing you can do. You just say not defined, right? Because you cannot plug it in. There's no function taking -4. F of -2 look like it's a blue function. So something squared plus 3, and that something will be -2. -2 parentheses square is positive 4, plus 3 is 7. All right, we finished the section. Yay. All right, good luck. Have a wonderful weekend, and I'll see you again on Wednesday. Bye bye.